Okay, well, thanks for coming to the session. My name is Steve Grisey. Sometimes it's a little bit hard to explain what you work on. Huh? Like I tried to explain, maybe this pipe fitter analogy this morning was a good one. I guess I worked for a long time for some software companies. I worked at Esri for a while. I worked in a couple different companies before that. I've done a lot of consulting work, and that's a lot of what I do today. For a long time, I worked on sort of the leading edge of some technology efforts, but then it occurred to me as I had more experience and I worked with more people that it's sort of like mountain climbing. It's one thing for someone to get to the top of the hill and have the latest and greatest functionality or the latest, greatest thing in their piece of software, but it's probably more important to get everybody up the hill, right, and get things moving along. And in some ways, this presentation may seem like a little bit of an outlier. Like I had somebody say to me the other day, a technology guy I talked to, he's like, well, geometric networks, that's kind of passe, isn't it? Like, I mean, people have been doing that for a heck of a long time. Like everybody did that a long time ago, right? Well, it turns out the people I work with, no. Lots of people haven't done this, and why? Because it's actually hard to do, right? The lines don't quite connect at the endpoints, and you have 7,000 problems to fix, and it's a little hard to do it in a day. So to contrast that, at lunch today, I talked a little bit about this, just, I'm always shopping my presentation to people before. And I mentioned to a few people about Smart Cleaner 2013, and all three of the users at the table wrote it down, right? That this actually helped me with this problem. And who the heck would ever find Smart Cleaner 2013? Has anybody ever heard of it? No, it's wicked though. Dave Campanis wrote things. Oh, we got one that's actually heard of it. Yeah. It's not Dave either, the guy that wrote it, so that's good. So anyways, I do a fair bit of work. In the Toronto area mostly, but I do a lot of work. I've been doing actually a lot of work at University of Washington at Seattle, building a 24 million square foot floor plan system, including interior navigation and other capabilities. So I get to work on lots of interesting projects in lots of places actually, and people are kind of surprised. And sometimes I use that plumbing analogy, right? Like if a plumber was working for a lawyer, or a plumber was working for a doctor, or a plumber was working for an astronaut, it would just be plumbing work. Like why does everybody worry that I have to work in 12 different industries, right? It doesn't really matter that it's always plumbing work, right? There's a lot of what we do. Outside of the details of that, I guess I like to ride motorcycles. I spent in the last 5 days, probably rode 750 kilometers around the Lower Mainland on some bikes with some friends and had a really good time doing that. My lovely partner Sarah and I have a 40-year-old boat that we keep going on Lake Ontario. I guess I'm odd in a lot of ways, but one of the ways I'm odd is I'm really excited to get home. The new water pump that I just ordered from my old boat showed up while I was out here, so I get to go home and put that on. I'm not sure I'm going to enjoy it while I'm doing it, but that's the kind of thing that I like doing. And I do really enjoy this thing of getting teams up to the top of the mountain, right? Getting everybody up the hill. I always sort of think if you're in a climbing expedition or you're a bike trip or whatever, there's two important groups, right? The people leading and people in front that are finding where to go and picking the routes. And there's the other people at the back who are making sure everybody gets up the hill, right? And as I've gotten a little bit older and I've worked on a lot of different projects, I'm more interested in getting everybody up the hill, right? And this is an interesting project because I taught for several years. I've done a ton of work at the City of Barrie. They've implemented a big city work system. They've done lots of different things, but they never got around to actually building geometric networks. And so I signed up to do this project over the Christmas holidays one year. And in terms of visualizing failure, geez, I forgot that this was actually hard. I told them, oh yeah, I can do that. I've done that before. It's no big deal. And then I pulled out FME and I sat down and I thought, ooh, this is going to be a long Christmas holidays. And I really wanted to ski, right? I wanted to ski more than I wanted to work on this thing. So anyways, over to geometric networks. So how many people here know about geometric networks or have heard of them before? And okay, so I won't spend too much time talking about why they're important. But essentially, what happened in Barrie is that they were increasingly wanting to get more of the tools out in the field. The operations people wanted to be able to say, okay, we've got a leak here. We need to trace out and find the valves that we can shut off. We want to skip over inoperable valves. We want to do some other things. There's quite a demand for kind of export to hydraulic modeling software to have everything connected and be able to do that kind of work. It's interesting too that you see when you build a geometric network, you highlight a lot of data quality issues. Like one of the legends, I don't know whether it's an urban myth or not, but I heard one time in Vancouver, somebody was sitting at a meeting and they have several huge pumps all around the area where we are, that in case of a major downtown fire, they would connect those up and they'd feed it through the water system and they'd use that for fire suppression in the downtown area. Well, somebody was at a meeting and they said, well, it doesn't look like on your map those pumps are connected to anything. And that led to a few questions. And actually, nobody in the construction project had ever actually connected the pipes up to the pump. So if there was a fire, it would have been a big deal. So data quality, I mean, that's a pretty bizarre example of it, but there's lots of data quality issues that I think these kind of things highlight. And there's also kind of an important thing here for operational decision making and sort of moving into a modern area of managing the networking kind of real time. If we do this and we do this, what happens over here? And there's an engineering and other things involved, but sort of the foundational part of it is a connected network. And basically the way that geometric networks work is they are designed to have coincidence, right? They must be geometrically coincident and snap together at the endpoints of lines and midpoints, and things can connect sort of mid-span or along the lines, but points have to be on the network as well. And usually for me, thinking about that kind of visualizing failure thing, I always have this deep thought whenever I go into one of these kind of networks, and I think, how close is close, right? You want to snap things together, but there are things that are short that are correct, and there's things that are longer that are incorrect. And how do you solve this problem is sort of, for me, the perennial issue of how close is close, right? And maybe it's like, I don't think there's any Greek myths about this, but it seems to me this is like the eternal question of building networks and putting together data like that, is how close is close. And the answer in this particular project is 10 centimeters and 1 centimeter. And I'll show you a little bit more of that as I go through. But it turned out in this particular data set, there were some things that were less than 10 centimeters long that were valid, and there were other things that were greater than 10 centimeters long that 10 centimeters long down to about 0.01 or 1 centimeter. And there were some other things beneath 1 centimeter that I wanted to do as well. So I wanted to move the lines within 10 centimeters, let's say, and I wanted to move the dots within 1 centimeter, right? And that's basically the gist of the exercise, although it's a little more tricky than that. To do this, I basically went through and spent some time looking at the source data. Anytime I've done this, people had told me some stories about, well, you'll find valve pits like this, and you'll find this like that, and here's another situation we know about in the data. But, there's sort of like stories, right? They're never really true in the data, so you really have to spend some time looking at it. So what I did on this project, and a lot of what I typically do in my process, is I spend the first chunk of time really trying to analyze and understand the issues in the data. These days, I use a lot of views, and I use, in this case, this is SQL Server, I use some ST functions on the geometry to kind of compare things and look for lines that started and ended at the same place. I looked for duplicate points, I looked for short things, I looked for long things, I looked for all kinds of different things, and basically built a set of views. And those views I would add into ArcMap, or I would use them in different ways to explore and kind of look at what the patterns were and understand things a little bit. The second thing I typically do in the beginning is just try building the geometric network. Every time you run that geometric network loader, it's a little bit, that's not good. It's a little bit destructive on the data. So I sort of make a copy of it and try this, because you snap things around and move them. What happened in this case, and this is always a little bit disappointing when you go to work on one of these projects, is you come out with something like 780 errors. And that seems like more than 20 hours of work to me when I first look at it, right, to solve that problem. And in this case, most of the issue actually was a whole bunch of junctions that weren't connected to any edge, or basically a bunch of points that weren't on any line. Maybe the next screen looks a little bit better and won't be so jerky. And so some of the issues in that source data, if you look at the one on the left there, the classic sort of undershoot from below and an overshoot from above, right? You get lines that just sort of overlap and don't quite meet, and you can kind of imagine trimming the one line and extending the other line. The one in the middle here, those are two lines that are close, but not really close. They're about, 6 centimeters away? Yeah, about 6 centimeters apart from each other. And then there were some other weird things in the data. So there's actually multiple lines here all in this area, and they're all less than 10 centimeters long. So it's kind of garbage, right? Almost like chalk dust on the map, right? That nobody would have probably ever zoomed in that much, and they kind of mistakenly added more things. But those are pretty typical in data sets like this. So what we want to do is grab those endpoints and move them around and connect everything back together. And in some cases, we want to get rid of the small stuff. I think as I worked through this, there was also some examples of very short line segments. And I think everything less than a centimeter that was a line, I just eventually deleted it because it was actually not real data. Again, it was sort of like chalk dust, right? It was too small for anyone to ever see. Short lines is another issue. So in this case, we have a 10 centimeter long line that is connected to two other lines. And I don't want to get rid of that. That's actually a valid thing, and it's an asset, and it has an identifier. And I think it had different material characteristics in this case, so I didn't want to get rid of those. So you have these sort of problems where things are more than 10 centimeters apart, but there's also things less than 10 centimeters long that are actually valid. Another tricky one in the geometric network is that the lines can't be multi-part and they can't be self-intersecting in any way. So you get into these sort of cul-de-sacs and rings where the line might begin and touch itself at the end or begin and end at the same spot. And so what we want to do in this case is kind of end up having to split that thing somewhere, create a second pipe in the geometric network and have a new asset ID and do a little bit of cleaning up on that, right? This whole thing is linked to CityWorks, so we had to be a little bit careful with work order history and work orders and asset identifiers and things like that along the way. So that's another tricky one to handle in this scheme. Points, you get similar issues, right? In this case, the hydrants are not on the mains and they're off by meters, right? It's not like these hydrants are close. It's like that's just not close at all, really, right? But we wanted to do something with those things. But some of it got so complex here that I didn't even really know what it was supposed to be, right? Were the dots in the right place and someone should have drawn a little short piece of pipe to them. And so we handed a bunch of this back and asked a bunch of questions of the operations people to sort it out. But it's a good example of that kind of data issue that the operations people can use to help feed into things. So we didn't really address that when they were a long distance away. Because on the other side of it, here's another short pipe. It's only 85 centimeters long. And it's actually two services coming off of there. It really is less than a meter apart. So we wouldn't want to snap all that together and get rid of things, right? And this, in a water network especially, this is the sort of classic problem. There are multiple services that are actually close together in the real world, and you don't want to get rid of things along like that. And so that's a particular challenge in this sort of how close is close thing. And it sort of led me to two passes through the data, one to handle this stuff that was sort of 10 centimeters long and shorter, and other ones that were sort of 1 centimeter away. And I'll go through that in the workbench here. So we'll see. Anything to do with FME is really jittery on my laptop, so I don't know whether it's a resolution thing or what the deal is. But anyways, you won't be able to read any of that anyway, so let's not bother looking at that for too long. What I'll try to do is we'll see if we can get something going on the FME side here. There's really a couple of different things that are going on inside of this workbench. And again, probably one of the main takeaways, because it took me a while to find this tool, I was trying a couple of different ways of doing this. And it turned out that this Smart Cleaner 2013 was actually pretty good. So on this project, I'm going to talk about water. We also did some stuff with the sanitary or the sewer system. And we did some work with roads as well, which is actually relevant for a lot of people. But for me, for demo purposes, it's not really as exciting as the water stuff, because there's a lot more errors and a lot more issues. So now I'm wondering, is it less jittery if I don't have it full screen? That's not too bad. I strive to be resourceful, if not brilliant. All right, so here in the workbench, I'll just spend a few minutes on this part of it. In this upper section here, I'm actually reading in the water mains and the services. And there's sort of three main paths that things follow here. The first path is there's a number of things in the data that are inactive. And if you remember geometric networks, there's an enabled field. And anything that's not enabled or set enabled is equal to false won't work as far as tracing and connectivity and other sorts of things. So typically this is abandoned pipe or things that are inactive or things that are permanently out of service that we're doing here. So we got rid of those things right away. And essentially what happens in the workbench is that the inactive stuff, it sets a value, and basically there's a dynamic writer here, and that dynamic writer just writes out the valves and the mains and the hydrants and everything is enabled false. We don't do any snapping or any more work with it, right? Because it's not something that we really want to do for that kind of data. The two main paths up above are really two passes through this Smart Cleaner. And I mentioned before that there was actually a couple of things in here. The one is, here's the snap value. So this is sort of the snap value that I set in here is one centimeter, like I mentioned before. And that's really the idea of how far am I going to move points to snap to lines, roughly speaking. And then there's a second part, which is how far am I going to move the ends of the lines to snap to each other? And that's 10 centimeters in this case. And I found that that was sort of the best balance in this data set between maintaining this sort of geometry and the initial shape of things and getting most of the connectivity. I fiddled with this quite a bit, and that's why those are parameters. Because if you went to a meter, I blew away a lot of stuff and it got messy. But if I went, in this range, it was actually pretty good. So this Smart Cleaner 2013, which I'm not going to spend much time explaining, was the transformer that I found. It's something you can get from FME Hub. It's something that's there. Somebody asked me, how did I ever find this? I don't even know. I was looking, I found a blog, and I just started using it. It does a really good job, though. The two main parameters coming into this thing are really, how far do you want to extend things to meet out to the other lines, and how far do you want to trim things to bring them back, right? Those are sort of the two parameters going in. So that, if you remember back to that original picture with the lines with the undershoot and the overshoot, those two variables can control how far it would go in and out. And in my case, I said 10 centimeters. I want to do both for 10 centimeters. That's the top one. But then there were actually lines that were less than 10 centimeters long, and I did a second pass where those ones are only going to go 5 millimeters, right? So those lines, I moved the littler lines, because if I moved a 10 centimeter line, I could move it down to 0, or I could move, it's too much, right? I need a little short line, I want to just move it a little bit. So there's two passes through this that's really going on in the Smart Cleaner. And it does some topology construction and things like that. I won't spend too much time on it, but that's really what goes on in here. Towards the end, once that comes out of there, there actually can be features that are split up, but they would maintain the original geodatabase ID. So by feature type and GeoDB ID, I sort of join them back together again on the other side, because they can be chopped up quite a bit, but then this would join them back together again. So that's one thing that goes on in there. I do some feature merger just to go back and rescue the attributes, because the joiner sort of drops all the attributes on that side. Do a little bit of work to try and snap things back together. And then we get into the other side of it, which is down below. These are all the point features. So we have pumps and valves and structures and hydrants and other things that we wanted to try and do some work to snap those together. So again, the inactive stuff we write out right away, but the interesting part of that is we try to snap the points to the short lines, and then in another pass I try to snap the points to the longer lines if they didn't snap to a shorter line. And eventually all of this stuff at the end just goes out to a dynamic writer. And dynamic writers don't look that exciting, but they're really good, because everything that came through, whatever the FME feature type was, it will basically pass that through and write the rows into the table. So I won't run that. We lost a couple minutes here just getting set up video-wise. It takes about 6 minutes for this to run through. It creates about 164,000 features. And the results were pretty good. There were, like I say, there was some work to be done to go back and clean that up and to look at it from the operations side and some deeper questions that were there. But it did about an 80 to 90% job, I would say, on the first pass, which got rid of, hundreds and hundreds and hundreds of issues, right? And most of them were less than 10 centimeters long and hard to fix for the people that were doing that work, right, at the city. So that's the gist of that. Let's go back to the slides here. So essentially the approach that I took on this was I went through and I evaluated the data issues. Like I said before, I used some views to do that. I used some different techniques. I did a little bit of semi-automated stuff. I ran the geometric network loader a bunch of times, and I started to get dialed in what exactly the issues were that I could fix and the ones that I couldn't. I put together a pretty decent document that described those steps and how to put things together. And I automated the process. A long time ago, I did a presentation. I was building a data model, and I did a presentation about how it took me 6 times to load the data and get it right. And somebody left on the comment card, they said, "What an idiot, it takes him 6 times to load his data." And have you guys ever done 6 times? Like, I automate this stuff all the time because you always get something wrong, right? Like, I worked on something 2 days not too long ago, and the city name didn't come through right? And we didn't notice until 2 days later, right? It's always better to automate this stuff, right? So I spent a bunch of time automating and putting it together and building something fairly solid from end to end for the routing through of this. So there's some other transformers in there to handle some of the snapping, anchored snapper, a line snapper, and kind of things like that are going on. But the really heavy lifting part and the sort of thing that I got onto on this was using that smart cleaner transformer to do the cleanup. And the result of it was actually pretty good as far as the coincident features go. This is probably not going to look very good, so I won't spend too much time on it. But let me see if I don't have it full screen on that. Is that better? Look at that. It's like a full screen issue. Weird. So that, if you don't know, that's part of Lake Simcoe in Ontario, and that's basically the City of Barrie. You can see a couple of, purpley things and red dots and other stuff that are going on there. So it didn't work 100%, but usually in these things, they don't work 100%. And you can see in here when you zoom in a little bit closer on the right-hand side that there are some things that aren't connected that are just far away from other things. And there are some things that should have been connected that really didn't work out quite right. So we had a couple of challenges in addressing that. A lot of it having to do with the services and cul-de-sacs and other stuff like that. There were still a few challenges with that part of it. So I don't have too much more to go through in terms of the presentation. I don't want to fiddle around with ArcMap because of the way the screen's been flickering. I don't want to try yet another thing that might not work too well. I guess what I wanted to close with was there's a couple of points to this presentation. One of them is, if you haven't used the smart cleaner, find it because it'll help, right? And it's useful for roads, it's useful for any kind of pipes, it's useful for all sorts of line work that you want to snap together in different ways. And like I found, you can use it a couple of different ways at the same time, right? Different parameters based on length and other things like that to do a pretty good job of cleaning up linear networks in general. But I wanted to come back on one of my comments from earlier in the presentation too about sort of getting the team up the hill. And I think there's a little bit of a clue for the future in things like this, right? Because this is just a little side project that somebody did. Maybe it was one of their 1 week things, or maybe they thought it was just a good idea to do to get the news out about it. But I think for a lot of us who are practitioners and are busy and trying to do lots of different things, these kind of transformers are super helpful, right? Because they solve about 12 different problems at once. And I've worked with SAFE for a long time. It's often very difficult if you don't work in their building beside those people to get the insight on how to do something, right? And for me, these kind of macro level things, or these things about kind of a little bit more solution or a little bit more purpose-oriented things would be a useful set of transformers that would make it better for people who aren't experts, right? To come in and to be able to know a lot about water utility data, but not that much about FME, and actually get really good results, right? On putting the data together. And there's no other tools like this, right, for doing this kind of geometric manipulation that's anywhere close other than just sitting down with a programming language and starting from scratch, right? So it's pretty powerful. I just think that this is sort of like the next level for all of us, right, is to find some of these patterns and things. And it's good confirmation for me because at lunch when we mentioned that the 3 people actually wrote down the name of the transformer, and one even looked on his phone to make sure he could find it, right? And those were like, one guy was a forestry guy, another person was actually doing some work on streams in Australia, and another person was doing pipeline work, right? So it's a fairly universal thing for all of us, right, this kind of stuff. So I'd encourage you, I mean, everybody at SAFE is super helpful, right, and positive on helping out with this sort of thing. So I think we should throw them some more ideas like this, right, to chew on and to put together to help us out with this kind of problem, because it's a tricky one for lots of us to figure out, even if you've been doing this for a while and you already got some gray hair trying to figure things out, you know. Anyways, that's it for my presentation. Thanks a lot for coming, and we'll take some questions now if you guys have got anything. Go ahead.
Were a lot of the problems with connectivity and that sort of thing, were they because of just the way things have sort of built up in the GIS after years and years of being entered in? Or?
Yeah. So the question is, did all those issues just sort of creep in as people were digitizing and doing the data management over years? And that's what it was, right? They were editing without the geometric networks, so they didn't really snap things together, and it looked fine on paper, and it looked fine from the CityWorks side. Everything looked fine, but it just wasn't fine, right, when you zoomed in really close and really looked at it and sort of analyzed it, right? It wasn't as good as it seemed, for sure. Yeah, go ahead.
How does Barrie handle what we call in ArcGIS call it fictitious pipe? You have a key that's flanged to a valve, which is flanged to a main. Technically, a linear segment node, a fictitious linear segment to a key.
Right. So those are like sort of like short segments is the thing, right? Yeah. Right. Yeah. So the question is, in general, I think when you have short segments, or a lot of times there'll be 2 things that are super close together and there is no pipe between them, right? Or it's not really on the pipe, it's actually over here, but you want to have it connected even though there's no physical thing between the 2 things, right? And I think the practice here and what I've suggested to people for a long time is sort of that 10 centimeters or 6 inches, right? You might as well just create something that's short, and you can call it a virtual thing, like in the hydro side or in the water resource side. A lot of time we had these sort of virtual segments or virtual streams, right, that people would connect. I think I'm just going to turn this off so nobody gets a brain problem. Is that okay? Yeah. Does that answer the question okay? Yeah. Anybody else? Anybody else trying to build geometric networks on this kind of thing or other kind of network data sets right now? Yeah. Any luck?
Yes.
Okay, good. A question?
Currently, we have a geometric network, and Nashville is discussing the possibility of simplifying it because it requires too much maintenance and staff time to do the data entry. Any comment regarding that when it goes out to haystack or water software?
Yeah, yeah. Yeah, so the question is, there's a fair bit of overhead that goes along with that geometric network editing, right? It's a little bit heavy, and Esri's working on some next generation tools, right, for network management. But yeah, a lot of times the network side of things, they treat it a little bit differently, right? They might have 2-port nodes, or they might have other stuff in modeling software. So those kind of transformations can be pretty tricky. I know some people that implemented without a geometric network, and it works okay, but you really have to be careful with snapping and tools and build some other QA tools. And some of the directions I've seen people go with it is to have a simpler structure, but maybe build some FME tools or some database views or other things that actually run the QA so the editors can get good at, sort of touch once editing and know what the issues are right away. I've seen that sort of thing work well, but yeah, there's no great replacement for that stuff yet, for sure. Anybody else? No, that's good. Thank you.